Good afternoon, everyone. Welcome to the first week of the third quarter. I am your teacher, Romel Palado. Before we are going to proceed to our topic, may I ask you first this one. How's your new year? Did you celebrate it well? Of course. New year is a new life. Let's begin it by learning and never stop learning. So our topic for this afternoon is all about solving linear inequality in one variable. Here's our objectives for today's discussion. First, after going through this module, you are expected to identify properties of inequality, illustrate linear inequality in one variable, find the solution set of linear inequality in one variable by algebraic method, solve linear inequality in one variable, and graph the solution set of linear inequality in one variable, and solve word problems involving linear inequality in one variable. Before we are proceeding, let us first define these terms: inequality, solution of an inequality, solution set, and solution sets. Then, let's differentiate what is equality and inequality. So, inequality is a statement that shows two numbers or expressions that are not equal. For example, we have 5 is greater than 3, or 2x is less than or equal to negative 6. Solution of an inequality. It is a value of the variable that makes the inequality true. For example, we have x is less than or equal to negative 3 is a solution to the inequality. 2x is less than or equal to negative 6. We have also a solution set. It is the set of all solutions. For example, we have negative 3, negative 4, negative 5, negative 6, negative 7. This set is a solution set of 2x is less than or equal to negative 6. Then we have also solution sets. Are written in the set notation using braces. Solutions may be given in a set notation, or they may be given in the form x is equal to a certain real number. For example, x such that x is less than or equal to negative 3 is a solution set expressed in a set notation. Now, let's differentiate first inequality and equality. When we say equality, there is a connection of two expressions. It was interconnected with equal sign. While inequality, we have a statement shows two numbers or expression that are not equal. So they are not equal, while inequality, that is equal. Inequality, not equal. Then, in equality, we have one solution. While in inequality, there are a lot of solutions. Two or more solutions. The properties of inequality. First, we have addition and subtraction property of inequality. We have addition property of inequality. You can add the same number to both sides of an inequality and the statement will still be true. In numbers, if we have 3 is less than to 8, if we are going to add to both sides, it becomes 3 plus 2 is less than 8 plus 2. Then we are going to simplify 3 plus 2, that is 5, and 8 plus 2, that is 10. So, 5 is less than to 10. It is true. While in algebra, if we have A is less than to B, if we are going to add C to both sides, we can have A plus C is less than B plus C. Next property is subtraction property of inequality. You can subtract the same number to both sides of an inequality and the statement will still be true. In numbers, if you have 3 is less than to 8, Then if we are going to subtract 2 by both sides, we have 3 minus 2 is less than 8 minus 2. Then if we are going to simplify, 3 minus 2 that is 1 and 8 minus 2 that is 6. So 1 is less than to 6. It is true. While in algebra, we have A is less than to B. If we subtract C in both sides, it becomes A minus C is less than to B minus C. For example, solve the inequality m plus 12 is less than 20. So the given inequality, which is m plus 12 is less than 20, since 12 is added to m, we are going to subtract 12 both sides of the inequality to undo the addition. So it may becomes m plus 12 minus 12 is less than 20 minus 12. Then after that, we are going to simplify, wherein 12 minus 12 is equal to 0 and 20 minus 12 that is 8. So therefore, m is less than to 8. So the solution of the inequality, the solution set is m such that m is less than 8, read as m such that m is less than 8. What property of inequality is being applied? In the previous slide, we have the subtraction of inequality being applied is subtraction property of inequality. The solution of the inequality may be written in a solution set expressed in a set notation like this: m such that m is less than to 8. All values of m less than 8 are solutions of the inequality. So what are those less than 8? Or what are those integers that are less than 8? Those are 7 and negatives. 7 below, that is the solution sets. To check if m is less than 8 is a solution, let's take some values of m less than 8, for example 7 and 6, and substitute them to the inequality m plus 12 is less than 20. Let's check if 7 is a solution. M plus 12 is less than 20. We are going to rewrite the given inequality. After that, we are going to substitute the value of 7 to m on the variable m. So it may becomes 7 plus 12 is less than 20. Then we are going to simplify. 7 plus 12, that is 19, is less than 20. So it is true. 19 is less than 20, hence the statement is true. Now let's check if 6 is a solution. Write again the inequality m plus 12 is less than 20. After that, substitute 6 on the variable m. It becomes 6 plus 12 is less than 20. Wherein we are going to simplify 6 plus 12, that is 18, is less than 20. Hence, the statement is true. To graph the solution set m such that m is less than 8, just locate 8 in the number line and draw an empty circle. Since the inequality symbol is less than, then extend the arrow to the left. The graph of the solution set m is less than 8 is illustrated in a red arrow below. This one. So, those numbers who are less than to 8 will be in the red arrow. So, it means that those numbers are solution on that given inequality. So, the empty circle of the tail of the arrow means that the real number through which it lies is not a solution of the inequality. In this case, 8 is not a solution of the inequality. M plus 12 is less than to 20. Why? Look. Note the graph of the solutions is illustrated in red arrows. To be guided in graphing the linear inequality in one variable, follow the table below. So if the symbol is less than, empty circle extended to the left of the number line, while it is less than or equal to solid circle extended to the left of the number line. If it is a greater than, empty circle extended to the right of the number line. If it is greater than or equal, extended to the right of the number line with a solid circle. Now, you can differentiate what is greater than or equal to, less than or equal to. So the red arrow extended to the left of 8 because the symbol is less than. Why is the tail of the red arrow an empty circle? So the tail of the red arrow is an empty circle because it implies that 8 is not a solution of the inequality m plus 12 is less than to 20. To prove that 8 is not a solution to the inequality m plus 12 is less than 20, let's check. For this, we have m plus 12 is less than 20, then substitute 8 on the variable m. So it becomes 8 plus 12 is less than 20. Then we are going to simplify, wherein 8 plus 12 is equal to 20 is less than 20. So it means the statement's false, because 20 is not less than 20, rather it is equal. So all values of m greater than or equal to 8 are not solutions of the inequality m plus 12 is less than 20. Example number 2. Solve the inequality b minus 5 is greater than negative 7 and graph the solutions. We have, first, we are going to rewrite the given inequality, which is b minus 5 is greater than negative 7. Since 5 is subtracted from b, add 5 on both sides on the inequality to undo the subtraction. So it becomes 5 or b minus 5 plus 5 is greater than negative 7 plus 5. Then after that, we are going to simplify. So b minus 5 plus 5, that is 0. So what left is b. While negative 7 plus 5, that is negative 2, since they don't have the same sign. So we are going to subtract and copy the sign of the larger integer, which is negative 7. So the solution of the inequality is b is greater than negative 2. So therefore, b is greater than negative 2 is the solution of the inequality b minus 5 is greater than negative 7. What property of inequality is applied? We have the property of inequality being applied is addition, property of inequality. The solution set is b such that b is greater than negative 2. To graph the solution set b such that b is greater than negative 2, just locate negative 2 in the number line and draw an empty circle since the inequality symbol is greater than. Then extend the arrow to the right. The graph of the solution set is illustrated this one. We have the arrow is extended to the right since the symbol we are using is greater than. So all values of b greater than negative 2 are solutions of the inequality. So b minus 5 is greater than negative 7. To check if b is greater than negative 2 is a solution, let's take some values of b that is greater than negative 2. For example, we have negative 1, 0, and 1. Now let's substitute those values to the inequality. We have the equation b minus 5 is greater than negative 7. Then we are going to substitute negative 1 to b. So it becomes negative 1 minus 5 is greater than negative 7. So negative 6 is greater than negative 7. How about 0? We have b minus 5 is greater than negative 7. And 0, substitute to b becomes 0 minus 5 is greater than negative 7, and negative 5 is greater than negative 7, and it is true. Last, we substitute 1 to b. From the equation inequality b minus 5 is greater than negative 7. So 1 minus 5 is greater than negative 7. Then negative 4 is greater than negative 7, and it is true. Remember, solving inequalities is similar to solving equations. To solve an inequality that contains multiplication or division, undo the operation by dividing or multiplying both sides of the inequality by the same number. The red arrow is extended to the right of negative 2 of the number line because the inequality symbol is greater than. If it is less than, to the left. Why is the tail of the red arrow an empty circle? The tail of the red arrow is an empty circle because negative 2 is not a solution of the inequality b minus 5 is greater than negative 7. To check if negative 2 is not a solution, let's do the checking. First, we are going to rewrite the equation inequality rather, b minus 5 is greater than negative 7. After that, substitute negative 2 in the variable b. Negative 2 minus 5 is greater than negative 7. Then, after that, we are going to simplify. Negative 2 minus 5, that is negative 7. Because they share a common value, common sign rather. So, we are going to add the two integers. Then, copy their common sign, which is negative. So 2 plus 5, that is 7. So the answer is negative 7 is greater than negative 7. And it makes our statement false because negative 7 is not greater than negative 7. Instead, it is equal. Let's proceed with multiplication and division property of inequality. Multiplication property of inequality, you can multiply both sides of an inequality by the same positive number and the statement will still be true. If we have in numbers 7 is less than 12, if we multiply 3 both sides, it becomes 7 times 3 is less than 12 times 3. Then we are going to simplify it. 7 times 3, that is 21, and 12 times 3, that is 36. So therefore, 21 is less than 36. But in algebra, if A is less than B and C is greater than 0, then we can apply A times C is less than B times C. The last property of inequality is division property. You can divide both sides of an inequality by the same positive number and the statement will still be true. In numbers, if we have 15 is less than 35, then we are going to divide 5 both sides. It becomes 15 divided by 5 is less than 35 divided by 5. Then if we are going to simplify it, 15 divided by 5, that is 3, and 35 divided by 5, that is 7. So 3 is less than 7, and it is true. In algebra, if A is less than to B and C is greater than 0, then we can have A divided by C is less than B divided by C. For an example, solve the inequality 7A is greater than negative 42 and graph the solutions. We have, first, we are going to rewrite the given inequality, which is 7A is greater than negative 42. Since A is multiplied by 7, divide both sides by 7 to undo the multiplication operation. We have 7A divided by 7 is greater than negative 42 divided by 7. After that, we are going to simplify. So 7A divided by 7, that is A. Negative 42 divided by 7, that is negative 6. Note that the coefficient 1 does not necessarily be written, hence the final solution shown below. We have A is greater than negative 6 is the solution of the inequality. So therefore, A is greater than negative 6 is the solution of the inequality. 7A is greater than negative 42. So the solution set is A such that A is greater than negative 6. So all the values of A greater than negative 6 are the solutions of the inequality. 7A is greater than negative 42. What property of inequality is applied? We have the property of inequality being applied is the division property of inequality. The graph of the solution set illustrated below by a red arrow. We have this one. So the extended part is in the right side because the symbol that we are using are or is greater than. So the graph of the red arrow extended to the right of negative 6 on the number line because the inequality symbol is greater than. So that is what I am talking about. If it is greater than, it extends to the right. If it is less than, it extends to the left. Example number 2. Solve the inequality x divided by 3 is greater than or equal to 2.4 and graph the solutions. We have to rewrite the given inequality, which is x divided by 3 is greater than or equal to 2.4. Since x is divided by 3, we are going to multiply both sides by 3 to undo the multiplication. We have x divided by 3 times 3 is greater than or equal to 2.4 times 3. After that, we are going to simplify 3 times x, that is 3x divided by 3, that is x. Then 2.4 times 3, that is 7.2. The coefficient 1 does not necessarily be written, hence the solution shown below. So x is greater than or equal to 7.2. This time, 7.2 is included in the solution because we are using the symbol greater than or equal to. The solution set is x such that x is greater than or equal to 7.2. All values of x is greater than or equal to 7.2 are solutions of the inequality, wherein x divided by 3 is greater than or equal to 2.4. You can prove it by checking. But first, let's answer this question. What property of inequality is being applied? We have the property of multiplication property. The graph of the solution set is illustrated below, this one. As you can see, there is a black or red spot on that 7.2. And it was extended to the right because the symbol we are using is greater than or equal to. Multiplication or division of negative numbers on inequalities. If you multiply or divide both sides of an inequality by a negative number, flip or reverse the direction of the inequality sign. For example, we have solved the inequality negative 12a is greater than 84 and graph the solutions. So, first we are going to rewrite the given inequality. We have negative 12a is less than 84. Since a is multiplied by negative 12, divide both sides by negative 12 to undo multiplication. Then change greater than to less than, because we are dividing negative. So negative 12a divided by negative 12 is less than 84 divided by negative 12. Then we are going to simplify this one. Negative 12a divided by negative 12. What left is 1. while 84 divided by negative 12, that is negative 7. The coefficient 1 does not necessarily be written, hence the final solution shown below. A is less than negative 7. So therefore, A less than negative 7 is the solution of the inequality. Negative 12A is greater than 84. So the solution set is A such that A is less than negative 7. The graph of the solution set is illustrated below. This one. It was extended to the left since the given inequality is less than, so it extends to the left. All values of A less than negative 7 are solutions of the inequality. Negative 12A is greater than 84. Example number 2. Solve the inequality. B divided by negative 3 is greater than or equal to negative 8 and graph the solutions. This time we are going to rewrite the inequality, which is B divided by negative 3 is greater than or equal to negative 8. Since B is divided by negative 3, both sides by negative 3 to undo the division. Then change greater than or equal to less than or equal. Instead, we are going to use this time negative 3 times B divided by negative 3 is less than or equal to negative 8 times negative 3. After that, we are going to simplify. Negative 3 times B, that is negative 3B divided by negative 3, that is 1B. Is greater than or equal to, less than or equal to rather. Then we are going to multiply negative 8 times negative 3, so it becomes positive. Always remember that if you are going to multiply the two integers that have a common sign, that is a positive. So the solution of the inequality is B is less than or equal to 24. So therefore, B is less than or equal to 24 is the solution of the inequality. B divided by negative 3 is greater than or equal to negative 8. The solution set is B such that B is less than or equal to 24. The graph of the solution set is illustrated this time. This one. It was extended to the left. Since the solution set is less than or equal to 24. As you can see, 24 is also a solution of that given inequality. Here are the steps in solving the word problem. First, read and understand the problem carefully, then represent the unknown with a variable. Then, associate the unknown variable with the values given in the problem. Next, form an inequality using the values and variables. Solve the inequality using algebraic method considering the condition. And lastly, prove and check the answers. If we have the problem, Sarah has iron deficiency. She needs to take vitamins with iron. The recommended daily allowance of iron for female ages 14 to 18 years is 15 milligrams per day. Sarah has consumed 11 milligrams of iron today. Write, solve, and graph an inequality to show how many more milligrams of iron Sarah can consume without exceeding RDA or recommended daily allowance. First, we have the solution. Let M represent the additional amount of iron that Sarah needs to take. The sum of the amount taken and the additional amount is associated by the expression 11 plus M. Since the recommended daily allowance of iron for Sarah's age is 15, then the inequality becomes 11 plus M is less than or equal to 15. Then after that, we are going to solve the inequality. First, we are going to write the inequality. 11m is less than or equal to 15. After that, we are going to subtract 11 from the inequality. 11 plus m is less than or equal to 15. So the inequality becomes 11 plus m minus 11 is greater than or less than or equal to 15. Now let's going to simplify. So 11 minus 11, that is 0. What left is m. Then 15 minus 11, that is 4. So the solution of that inequality is m is less than or equal to 4. So therefore, Sarah has to take additional iron of 4 milligram. If you have any queries or clarifications for this topic, you may contact me to my cell phone number 0930-680-829. So, thank you for listening, everyone. Then, please proceed to your e-learning site for your activities and your quizzes. Again, this is your teacher. Good afternoon.